In this example, we're going to look at combinational logic circuits. So here's a list of tasks that you're asked to do. So first, to construct the truth table, and then write the sum of products in canonical form, and then derive the most minimized functions of each of the function f, and then identify which functions experience static hazards when there is propagation delay through the gate, and explain in which inputs conditions when the static hazards occur. And then you're asked to provide solutions to mitigate this hazard. So here the question set to construct the truth table. So you're given the functions f equals to a or b bar or c. So we can list down a, b, c, all the Boolean variables, and list down all the possibility. So we start from 0, 0, 0, and then counts towards the maximum. So we go from 0, 0, 0, 0, 0, 1, so it's always good idea to list down all the changes in the function. So here we got a b bar, so it's always good idea to list down b bar. And then the final function is all of a, b bar, or c. So means that either one of these Boolean variable has a 1, will give you a 1 in the output. So here we got a 1. And c we got a 1, give us a 1. Then here c 1 as well. Then b bar got a 1. A got a 1. Give us 1. Okay, so that is the truth table for the function f. And for number 2, we asked to write down the sum of products in canonical form. So if I were to write down in full, it will be a very long expression. So, but we know that this is the min terms. Where the min terms m0 is equals to a bar, b bar, c bar, I'm not going to list all of them, but just to give you an idea what the min terms is. This would be a, b, c. So the easiest way to write this as a sum of products in canonical form is to write it in a short form. So we can write down f is equals to the sum of products of 0, 1, 3, 4, 5, 6, 7. And then the third one is to derive the most minimized functions of each of the function f. So here I put down each of, meaning actually this example meant to have a few functions, but I break it up into a few slides. So to find the minimized functions, we can transfer these functions into a care map. So we can write down this on, transfer this onto a care map. So you go from 1, 1, then 0 is here, then 1. And the next 4 bit, they're all 1. So and then you can minimize the functions by drawing loops. So there's one loop here, loop of 4. So this loop of 4 gives you A. And you can also draw a loop of 4 here. That gives you B bar. And then a loop of 4 here that gives you C. So in actual fact, the functions that was given originally is the most minimized function. The fourth one. So from this, you can see that all the loops are overlapping. So there will be no static hazards. Same example, but with a different functions. So functions given here. So again, you're asked to construct the truth table. So first list down all the possibility. So we got an A bar, a C bar, So here we got A, B, C bar. So it's an N. So meaning is that only when all three of them are true, then produce a true. So we're looking at A, B, and C bar. So this is the only possibility that gives you a 1. Yeah. So let's write down the inverse of this as well. Then we have A bar C. So we're looking at A bar and C. So when both of them are true, they give you 1. So this is the only combinations. No, there's another one here as well. When both of them are true, that give you a 1. B and C, there will be these two. Then the final function f will be all of these 3 columns. So meaning that either one of this column has a 1 will give you 1. So go 1 here, 1. So go 1 here, give you 0. So this is the truth table of this given function. Two, to write down as sum of products. You can write it in this way. 0, 1, 2, 3, 4, 5, and 7. Camera. So go from 1, 1, 0, 1. So minimize the function f. So we can draw a loop of 4. Here's a loop of 4. They give you a bar. Here we have another loop of 4. That give you b bar. And here's another loop of 4. And they give you c. And that's the most minimized functions of the function f. Again, there's no static hazards. In this function. Another example with another different function. So we have b bar. So we can write down b bar here. A b bar. That will be these columns and this column. So 1, 1, give you 1. 1, 1, give you 1. Then we have B, C. That will be these two. So we got 1, 1, give you 1, 1, 1, give you 1. So we do, so A, B bar, or B, C, and then the whole thing bar. So let's do the function bar first, which means that this or this. So we got 1 here, we got 1 here. Therefore, f will be the inverse of this. And the function f is the sum of 0, 1, 2, 3, 4, 5, 6. And 3. Put it into Kemet. 1, 1, 1, 0, 0, 0, 1, 0. So we can write down here. You can minimize the function, drawing a loop there. You got f equals to a bar, then b bar plus b c bar. For so in this case here, you can see that in the care map, we have one loop here, and then we have one loop here, and there's no overlapping between these two loops. And therefore, this function here will experience static hazard if there is propagation delayed through the gate. And the hazards occur when A is low or 0, and C is 0 as well, and B changes. And we can draw out the timing diagram to see how this hazard actually occur. So if A and C is low, B change from therefore B bar is a delay, A bar, B bar. So A is 0, A bar is 1, B bar is 1, 1, 1 give you 1, and then B bar becomes 0, so you go to 0. But again, there is some delay. And we have B, C bar. So again, C bar, C is 0, C bar is 1. So when B is 0, this will be 0. Then B become 1. Then B, C bar will become 1 at slightly later time. And then become 0. And therefore our f functions, so when this is true, either one is true, so we got true, all the way to here is true, here is true, but here we have this bit here 0 and this bit here 0. You can see that 0, 0 gives us 0, and this happened a moment later. This is our static hazard. Okay, so when A is 0, C is 0, B going from 1 to 0 will give us static hazards. But B going from 0 to 1, here, there's no hazards in this case. So it's only when B go from 1 to 0. To eliminate these hazards, you can add an additional loop here. And make the functions to be equals to, so this is our original. And then we add an additional term, which is A bar, C bar, and that will, and this term here will eliminate the static hazards. This example here, now we see that there are 4 variables. So the previous function was 3 variables, but here we got 4 variables. So we need to list down again all of 4 variables, A, B, C, D. Then I got C inverted, A and B. C bar D Again, the functions are inverted, so it's easier if we look at F bar first. So it will be this column and with this column. So here 1 1 give us 1, 1 1 give us 1, 1 1 give us 1. Then the rest will be 0. Then the function f will be the inverse of this. F in canonical form. So we have sum 0, 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. To minimize the functions, again, okay, remember that when you list down the care map, the variable has to change one bit at a time, just like the gray code. And then we can put this into our care map. So 0, 0, 1, 0. So let's go 0, 0, 1, 0. and then you got 1, 1, 1, 1, and then you go 1, 1, 1, 1. And then we can minimize the function by drawing loop. So here we can draw loop of 8. And this gives us A. Can draw another loop of 8 here. This gives us B. And here we draw a loop of 4. And this is the minimize function. This is 3. 4. So I can see that all the 3 loops are overlapping, so there's no static hazard. So that is the example for combinational logic.